As explained in the previous video, we talked about a continuous random variable, the probability density function. So instead of having a table like before in chapter 5 or 4, like we have separate numbers, say x is 0 or 1 or 2 or 3. For each number, there is a corresponding probability. But in this chapter, we cannot make a table anymore because there are infinite many values. So we always have a continuous curve for the probability. And you can see from here we have all kinds of different probability density functions, and some of them are symmetric, some of them not. And so next we're gonna look at a few, like this one. It's symmetric about this middle line here, and we're gonna see how we calculate the percentile like before. When we have a list of numbers, suppose we have 50 numbers. If we want to find out the 15th percentile or 25th percentile, we just take 50 multiplied by, say, 15% or 25% to find that position first, where the 15th percentile number is, or where the 25th percentile number is. When we find the position, we can determine that number. And here we don't have a list of numbers. And how many numbers do we have? Actually, we have infinite many numbers, so we we cannot use that formula anymore. So what we do here is the definition will still be similar for mean, and it's like the average, and median, it's like the middle value. And but because the former definition, the calculation involves calculus, so we don't go into the details, and just have an intuitive idea what the mean and the median are, and it's like before. So the mean is the balance point of the probability mass, and the median is the value that divides the area into two equal halves. So if we look at the mean, the first picture, because it's symmetric, so the middle line will divide the area under the curve into two equal halves. So this point right here is not only the mean but also the median. But if we look at this one, the left side is kind of long. These values are small, so the mu, which means the mean, it's going to, because we take the average of the values, so it's going to be kind of it's not going to be in the middle. It's a little bit on the right side of the middle. So from here to here, you can see it's closer to the right side. And the median that divides the area under the curve into equal to half. So we can see, of course, we got to move to the right also, and this area is going to be equal to this area. Okay, and all the calculation will involve calculus, so we just look at the picture. And here this one would be similar, so because the left side, the value is kind of bigger than the right side, these small values, so the area of this part will be closer to the area to the right. So we should know that those curves will continue forever to the left and the right, but the area under the whole curve is equal to 1. So the area to the left side will be 1/2, 0.5. The area to the right side will be 0.5, and the same here, 0.5 and 0.5, and the 0.5 on the left, 0.5 on the right. So that's the median. So median will divide area into two equal halves. But the average mean, it's right here. So sometimes mean and median, they're the same number, but sometimes they're not. So in this case, mean is a little bit to the left, in this case mean is to the right, because we take the average of the numbers and then the density function, and so it's a little bit to the right here. And so in order to calculate the percentile, we look at the example. Like we did before, we can do any percentile, 15th, even 80th, 90th. But these are the ones, typical ones. We do 25th percentile, that's the first quartile, 50th, that's the median, or the second quartile, and the third quartile, that's 75th percentile. So let's look at these two examples. F of x, again, means the probability function. And this is a curve, so it's not a table anymore, it's a continuous function, random variable. And we try to find out the median. So the median will be right in the middle, because this is a rectangle. So rectangle, the area, we know it's the length times width. So you can do the length, which is from 0 to 8. That's 8 times width, 1/8. So the area under this curve is, actually it's a straight line. The curve is a straight line, is equal to 1. So the half of it will be 1/8 times 4. So which will give us 1/2. So this line 4 right here, 4. So we say right here is the median. That is 4. And in order to find the first quartile, so the area to the left side should be 0.25, and 1/8 times 2, which is 1/4, and that's 0.25. And the third quartile, the area from the beginning to this point is 75%. So that's the 75% area. So that's the third quartile, because 1/8 times 6 is 3/4, which is 0.75. Okay, so the first quartile is 2, the median is 4, and the third quartile is 6. So this is a rectangle. We can do it this way. But if we have a triangle, we have to do some calculation. So to find the median again, it's the area that it's a point that divides, when you draw a line through the point, that divides the area into two halves, equal halves. So this is the area, again, it has to be equal to 1. If the area does not equal to 1, it's not a probability density function. So always, again, make sure the area is 1. So 1/8 times 8, this area is equal to 1. And also it's above x-axis, there's no negative. And this one, it's all above x-axis, so it's all positive or 0. And the area, we use the triangle, because this shape is a triangle. Shape under the curve is a triangle, so we do 1/2 of the base. The base from -2 to 2, it's 4. So 1/2 of 4 times the height, which is 0.5, and you can do a calculation, it's still equal to 1. So this is also a probability density function. But in the homework 6.1, some of them are, some of them are not. So you need to make sure first to check the area under the curve, make sure it's equal to 1. Use the length times width, or half of the base times the height. And second thing is make sure it's above x-axis. And so now let's do the quartile, first quartile, which is 25%. So we already found out this is easy because the shape is symmetric. So the middle must be the median, which divides the area into, this will be the left side, big triangle will be 0.5. This right side will be 0.5. Now first quartile, which means we need to find out the area that is equal to 0.25, so quarter. So where is that? So we do half of the length times the height, and we do this number right here is, what's this number? And we can do and we know the total area is equal to 1. So how do we get a quarter, which is 0.25? So what we do is we can say this point is x. We don't know this number, so we say it's x. And then we find out the function of this line here, and then we can find out if it's x, what's the corresponding y value right here. And then we use the formula, half of the base times the height, which is the y value of this point, and we let it be 0.25, and we can solve the equation to find out where this point is. So be careful, it's not necessary -1 or something, because this, we want to make sure this is half of this total area. So it could be different. It may not be the middle point of -2 and 0. So this calculation involves a lot of algebra, and the one in the homework, because it's a shape that looks like this, so it should be easier. What you need to do is you will have to, because the height is given, so 1/8. If I say I don't know how to find out this number, what I do is I make this one x here. So 1/8 the height times x is the area of this shape, and I want to make it equal to 0.25, and then I can find out this number is 2. And so in homework, you need to do 15th percentile, which means you want to make sure the area from here to here is 0.15, and the number given is, this number is different in the homework. So if I want to do 15th percentile for this example, what I'm going to do is I do 1/8, which is the height. I don't know where 15th percentile is, maybe somewhere here. I call it x. So 1/8 times x equals 0.15, and I solve for x. So, and I will get this number right here. So that is 1/2 the height times the width, which I don't know where it will be for 15th percentile. So I will just call it x. So the height times the length equals the area, which I wanted to be 0.15, because that's 15th percentile means. And so I solve this equation. I multiply 8 both sides. So 8 cancels 1/8. That gives me x. And the right side is 0.15 times 8. That's 1.2. So the 15th percentile will be 1.2, somewhere right here. And I notice that we don't need to go to the next whole number for the continuous variable, because when we do the random discrete, you have to, if you get a decimal number, you got to move to the next whole number. But if this is continuous random variable, so you would just say the 15th percentile is 1.2. Leave it as the decimal number, because discrete, the continuous variables, they can be any real number. It can be 1.2, 1.3, 1.22, anything.